Hey guys, Mr. Middleton here, going with our second lesson in our first unit in algebra. After these notes, you should be able to define a variable or variables in the context of a problem, and you should be able to write an algebraic expression or equation from words. So, a variable is an unknown or missing quantity. Okay, something we don't really know. Unknown or missing. Okay. A letter is typically used to represent the variable. We can use anything. If you're in that first grade and second grade, you guys have been doing this actually for a long time. You know, they might have put a square in there, an apple or something in the problem instead of a letter, but it's essentially the same thing. Something that's not a number that represents a number. Okay. Alright, so I told you last time that yesterday we dealt with expressions, simplifying expressions using order of operations. An algebraic expression is a mathematical phrase that includes at least one variable and does not include an equal sign. Okay. Now, an algebraic equation is a mathematical sentence that includes at least one variable and does include or does contain an equal sign. Okay, so you see that couple changes here. The algebraic expression is more of a phrase, and the algebraic equation is a sentence. Okay, equation does have an equal sign and the expression does not. Okay, the equal sign is like the word is. Again, which changes a phrase into a sentence. So if you look at these two examples, the number increased by 4. See how that's not a sentence, that's just a phrase. A number increased by 4. You just say like, what? What about it? If algebraically, we could write that as a number in increased by 4 plus 4. Okay. Now, an algebraic sentence, a number increased by 4 is 7. Okay, that makes sense. A number increased by 4, what happens is 7. Okay, a number increased by 4 is 7. So the difference between a phrase and a sentence, an expression and an equation. Okay, when we define a variable, we are stating what our letters represent or stand for in a specific situation. Without doing this, the variable has no meaning. And I'll clarify this. The variable has no meaning to us. Okay, and that's what's important. If we, just put x there and we solve it and we can do all the math, but we don't know what it actually does for us, then we're really wasting our time. So that's why it's important for us to know what's happening. I usually like to put letters there to remind me what it means. So even in these examples, I said a number increased by 4. Well, the N stood for a number. Okay, so even if I'm going through the math, I remember, yeah, I was talking about numbers. Okay, so let's look at this first example. It says define a variable and write an algebraic expression. I always think about this expression for the following phrase: Mark's weight minus 12. Okay, so I'm writing a variable for Mark's weight. I'd probably say M, Mark's weight, minus 12. I could see you doing W so that you know it stands for weight. But here's our algebraic expression that went with the following phrase. Okay. Alright. Now, the way I define my variables is I just underline it, and I underline what it's going to stand for, and I write the letter for it there. Okay, and that's all I'm really asking you to do to define your variables. Alright, so here's a practice that says define a variable and write an algebraic expression for each phrase. So, the quotient of triple a number and 7. So again, the thing that we don't know is a number. I'm going to write in. Alright, quotient, that means division. Triple a number, well, I know that means we're multiplying by 3. And 7, okay, that means what we're dividing by. So I can write triple a number, 3 in, and divide it by 7. Now some people will want to write it like 3 in divided by 7. I'll tell you that using it as a fraction is a little bit more applicable and probably more common for what you'll see in algebra. So if you do write like this, I tell you to tend to get away from that and start using fractions. Okay, a little bit easier to more applicable. All right, second one, 2/3 of the amount increased by 5. So 2/3 of the amount. We don't know what the amount is, but so that's a variable, but we're still going to use it. So 2/3 the amount, 2/3 times the amount, increased by 5. So increase to me, add. That's what it means. Okay. And then number 3, 1 less than the number of children. And this is trickier than it might seem. Okay, a lot of people trip up on these problems. And the reason is, for these first two, it was really easy for us to kind of write the numbers in the order that they appeared in the sentence. With subtraction, it's not that easy. Okay, 1 less than the number of children. So let's just, because I know I'm going to say C for the number of children, but let's just say there's 5 children. If there's 1 less than 5 children, how many children will we have? 4. Now most people tend to write the sentence as 1 less than the number of children. But again, if there's 5 children, 1 minus 5 would give us -4. There's not -4 children. This does not work out for us. Okay, so for subtraction especially, we need to pay attention to the order. 1 less than the children, we actually have to start with the number of children and take 1 away. Okay, because if there were 5 children and there was 1 less, we already know that would be 4. Okay, so if you have trouble, especially with this section, setting those problems up, always put in a number for your variable and see, does this make sense? Does this give me an answer that makes sense? Okay. Alright, so that's us using algebraic expressions, defining our variable, and completing our expression. Okay, flip it. Alright, so we're going to kind of do the same thing here, except now we're going to be talking about equations. Okay, so here we go. Again, defining the variables and then writing an algebraic equation for each sentence or table. So number 1 says the number of gallons of water used is 30 times the number of trees. Okay. There's my equal sign. So here we go. The number of gallons of water used, I'll just say G, is 30 times the number of trees, T. So 30 times the number of trees. So here we go. We have G equals 30 T. Okay, and just a reminder here, if we're doing multiplication in algebra, we do not have to write that multiplication X by there. We can just put the number next to the variable, and it is universally understood as multiplication. Alright, number 2, the number of goats is, so here we go, number of goats, G, is equal 10 less than triple the number of rabbits. Okay, again, less than. This is subtraction for us, and so we definitely need to make sure we double think or double check our thought process here. 10 less than the number of rabbits. So if there were 12 rabbits, 10 less than that would be 2. So we need to make sure that we put this number first. So 10 less than triple the number of rabbits. We want to make sure that R stands for rabbits. So I have G equals triple the number of rabbits minus 10. 10 less than triple the number of rabbits. Okay, not asked to solve this, and actually we couldn't solve either of these two because there's 2 variables in a sentence, but we set them up. That's what we need to do. Alright, last problem, a little bit different. It's from a table, not a sentence given to us. And so we have total change and change from $10. We'll put T here, C here. T stands for total change, or total cost. We want to say C for change. I think that'll help me out. I usually think of it as total anyway, and not total cost. Okay, so looks like all these add up to 10. So I'll say, well, I can tell how much something costs because I'm going to add um, the change. Actually, I'm going to take the change from $10. That's what it looks like. So my total cost should equal 10 minus the change that I got. Okay, and I can double check to see if that works. Total cost equals 10 minus 0. Yep, that works out. Total cost 9 equals 10 minus 1. Yep, that works. 750 equals 10 minus 2.5. Okay, so those work. So we're good with that. Alright, and so that's our equation from that table. Alright, so after this, guys, you should be able to define a variable and write an algebraic equation or expression from it. Alright, see ya.